All right, this is 4.1 Plate Tectonics. By the end of this lesson, you should be able to describe the geological changes and events that occur at convergent, divergent, and transform plate boundaries. I know that sounds an awful lot like a teen trilogy. To accomplish this goal, we will describe the features of convergent, divergent, and transform boundaries and explain the process of earthquake formation. But first, let's take a quick look inside Earth's core. It's the slow reveal for dramatic effect. Okay, so we have Earth's core. Now we're going to look at that a little bit closer. So we have a cross-section pie piece cut out here of Earth. We've got an inner core, which is a solid, outer core, also a solid, the mantle, which is a liquid, and again our crust, which is a solid, thankfully. But when we look a little bit closer at this mantle, we break it down into the asthenosphere, which is the upper portion of the mantle, and the lithosphere, which is the portion of the crust that the asthenosphere is right below that part. And this is important because this mantle and the convection currents within the mantle is what's driving our plate tectonics. All right. So within that mantle, we have what's called the convection cell, and this is the rising of warm mantle, which is less dense, which rises to the surface, cools, and falls back down. Now, when I say cools, I don't mean it's cold. It's all really hot, so it's more hot and less hot types of magma. So the magma is coming up from the outer core where it's being superheated. It's pushing up here, pushing these two plates apart, and then as it pushes up, creates new seafloor here, and then cools and falls back down. So this mantle convection cell, the magma is the liquid, and these plates are floating on top of them and moving around. And here is our theory of plate tectonics. Each of these is a tectonic plate. And what we're really going to focus on is this geologic activity that takes place at the different plate boundaries. So we have three types of plate boundaries: the convergent, divergent, and transform. We look first at a convergent plate boundary, and this is where two plates are converging, pushing together. And what happens here is that one of the plates subducts, so goes underneath the other one, where it's going to melt and be recycled back into that mantle convection cell. What we find at these convergent plate boundaries are mountains, island arcs, earthquakes, and volcanoes. So lots of activities here. So we see as this lithosphere, so this portion of the crust, subducts, goes underneath this continental plate. We see that it creates a volcano from that magma that's escaping here. So example of this would be the Himalayan mountains, and also we see here that Japan, an island arc right here, is converging between these different plates here. It's in the middle of a couple different plates. So now we have the opposite. We've got a divergent plate boundary, and this is where two plates are moving away from each other. And they're moving away from each other because that hot magma is pushing up between them and pushing them apart. So this creates a few different things. It creates seafloor spreading, which is new seafloor being produced. The old seafloor is being recycled in the convergent plate boundaries. It creates rift valleys, like the African Rift Valley. It creates volcanoes, and it also creates earthquakes. And this is a hotspot for geothermal activity, particularly in Iceland. And lastly, we have transform plate boundaries. And the transform boundaries plates are plates that are sliding past each other, and these ones produce earthquakes. And a famous one around here is the San Andreas Fault. Okay, so if you've seen the San Andreas Fault movie, that's the two plates sliding back and forth, creating these earthquakes. Okay, so this is important because we can see and track these earthquakes and volcanoes and determine the type of plate boundaries. So if you see what's called here the ring of fire, and this is where a majority of our earthquakes are taking place, which is in the island arcs around the ring of fire. So this Pacific plate here is converging with the plates, North American plate over here, all the plates on this side, plates down here, pushing. These ones are spreading apart, so pushing on the other plates, creating all these earthquakes all around the ring of fire. So you're going to want to mark that down. The ring of fire is very important. So I've mentioned earthquakes a few times, so we should probably discuss what those are. Earthquakes are the result of a buildup of stress between two plate boundaries. You'll notice earthquakes were listed as a feature of all three plate boundaries. But if you see one where it only lists earthquakes and that's the only thing that's happening, that's a transform boundary. So the stress of the two plates causes a sudden release in energy, and that's what we feel as an earthquake. So if we look here, we have a seismic wave, and that's that sudden release of energy. When that occurs underwater, we get what's called a tsunami. So tsunamis are these large waves caused by earthquakes or volcanoes underwater, and the sudden movement of the Earth's crust displaces the water, leading to potentially very large and very deadly waves. So you perhaps have seen these two tsunami hazard signs if you're in a coastal area that may be particularly vulnerable to these. So to summarize, our goal was to describe the geological changes and events that occur at convergent, divergent, and transform plate boundaries. We covered the three types of plate boundaries and discovered that all of them have earthquakes. Most of them also have volcanoes. And that is plate boundaries.